Good morning, students. We can see the module 2 of this course, bridges. The presentation is mainly with the introduction parts of the bridges. So it covers why bridges are needed, and the definitions, basic terms used in the bridges, the components of the bridges, forms of the bridges, and the forces mainly acting on the bridges. What is a bridge? Bridge is a structure that helps to cross the barrier from one place to another, and it is also helps to take the shortest, quickest and safest route to complete the journey. The bridges demonstrates the ways in which has to be the resourcefulness has to be applied to improve the movement of goods and people from place to place. The earliest form of bridges, probably the fallen trees, trunks, the stone slabs that is placed across the small gaps. In effect, it forms a simple beam bridge. This simple beam bridge comprises of a horizontal beam supported at each end by a vertical supports. We call that as a pier. So, this part we call that as a pier. Making bridges better. So, it is more needed when the modern transportation is updated with heavy vehicles, because the bridges nowadays they are used to carry tons of loads. So, we cannot only sustain with the simple beam bridges. So, we have to go for different forms of the bridge accordingly to with the load carrying capacity. So, IRC has given Indian Road Congress given the norms and the load classifications to design the different types of bridges. So, the classifications even defines the bridges to design in a very safety way. Basic bridges. The bridges has the basic form of forces. All the structures have pushers, pulls, twist acting upon them. Okay, so automatically it will affect by compression, tension, torsion and shear forces can play a role while designing the bridges. So, if the forms of the bridges or the classifications of the bridges means in terms of span, simple bridge, continuous bridge, cantilever bridge. In forms of material, stone bridge, concrete bridge, metal bridge, etc., precast bridge, etc. Form beam bridge, arch bridge, truss bridge, cable stayed bridge, suspension bridge, etc. Bridge terms, the basic terms. What is bridge? Already we have seen the definition. The structure that provides a way across the barriers, that connects, supports or links one thing to another. Arch bridge, a bridge that has a curved structure. The arch design provides strength by exerting force downwards and sideways against the abutment. Bascule bridge, a hinged bridge that acts like a seesaw sections, can be lifted using weights as a counterbalance. Beam bridge, the simplest type of bridge. It is made from a rigid stride structure resting on supports at either ends. Cable stayed bridge, a modern bridge of that in which the deck is supported by cables. The deck is supported by cables like this. Cantilever bridge, similar to the beam bridge. This design gets its support from counterbalanced beams meeting in the middle of the bridge rather than from supports at either ends. The two arms of the bridge are called cantilever bridge. Okay, so this cantilever and another arm, this will also act as the cantilever. Suspension bridge, a type of bridge in which the deck, this is the deck slab of the bridge, and hangs forms of wires attached to the thick cables. So we call this as the suspension bridge. Truss bridge, a type of beam bridge reinforced by a framework of girders that forms triangular shapes. This is a various pictures. This is the suspension bridge. This is the girder bridge, arch bridge. Loads and forces. We know load, the distribution of weights on the structure, and in forms of dead load as well as the live load. Force, a push or pull. A force is applied to the bridge in the form of a load. Stress, a force that tends to distort the shape of the structure. Compression, a force that tends to shorten, push or skews a structure. Tension, a force that tends to lengthen or stretch part of a structure. Torsion, the strain produced when a material is twisted. Shear, a force that acts to move a material in a sideway motion. Symmetry, an arrangement that is balanced and equal on opposite sides of a central dividing line. Buckle, a condition that occurs when structures bend under compression. Dead load, the weight of the self-weight of the bridge structure. Live load, the weight of the traffic using the bridge, the movement of the vehicles. The main components of the bridges. Abutment. Abutment is nothing but a mass of rock or concrete at either end of an arch bridge that keeps the ends of the arch securely in place so they do not separate and cause the bridge to fall. Anchorage. Foundations are concrete blocks into which the cables of the suspension bridge are secured. Beam. A rigid horizontal component of a bridge. Cable, a bundle of wires used to support the decking of a suspension bridge or a cable-stayed bridge. Caisson, a temporary structure used to keep out water during construction of the pier's foundation. Decking, the surface of the bridge that serves as a walkway, roadway or railway. Framework, a skeletal arrangement of materials that give form and support to a structure. Girder, a strong supporting beam. Hand or guardrail, a safety feature added to the sides of the bridge deck to prevent people, animals or vehicles from falling from the bridge. Keystone, a final wedge-shaped piece placed in the center of an arch that causes the other pieces to remain in place. Obstacle, something that stands in a way or acts as a barrier. Pier, a vertical support for the middle spans of a bridge, a column, tower or pillar for example. Pulley, a wheel used for hoisting or changing the direction of a force. Ramp, an inclined section connecting the shore to the deck of the bridge. Roadway, the area of the bridge along which traffic travels. It rests on the decking. Span, the section of the bridge between two piers. Support, an object that holds up a bridge and serves as a foundation. Suspender, a supporting cable of the deck. It is hung vertically from the main cable of the suspension bridge, also known as a hanger. Strut, a structural support under compression. Tie, a structural support under tension. Tower, a tall vertical support that carries the main cables of a suspension bridge and cable-stayed bridge. Triangulation, a building concept using triangles made from squares to enhance the strength of a structure. Truss, a framework of girders, some in tension and some in compression, comprising triangles and other stable shapes. Visor, a true arch made from wedge-shaped stone blocks that fit tightly together against abutments. Bridge materials. So different bridges are made out of different materials, and every type of material has certain elasticity, plasticity, so on. Elasticity is nothing but the ability to change shape when a force is acting on it and then move back to its original shape. Additionally, every material has certain limit of how far its shape can be altered before it becomes plastic or unable to regain its original form. This elasticity allows for different parts of a bridge to experience stress without breaking and in turn hold up the bridge as a result of normal force. This elasticity allows for different parts of the bridge to experience stress without breaking and in turn hold up the bridge as a result of normal force. The main types of stresses, the first one, this is compression, this is tension, this is bending, this is torsion, and this is shearing. We can expect these forms of stresses in any type of bridges. Compression is a pushing force that tends to shorten a member. Tension is the complete opposite. This it being a force that tends to lengthen a member. Two forces interact when you have an I-beam. On top and the bottom of the beam is where the tension and compression is occurring, while in the middle there is a little force acting on the beam. Due to the fact that there is a little or no force in the middle of the beam, there is minimal material there. Bending occurs largely in beam bridges and is basically self-explanatory. When a force acts upon the middle of the member or some part of the bridge, the material experiences compression on one side and tension on other, creating a bend. In the modern era, with the materials that we have at our hands, torsion has become eliminated in almost all bridges. It only appears in one type, the suspension bridge. With a hanging road deck, which is characteristic of a suspension bridge, winds can cause a strain produced by twisting. To combat the effect of torsion, designers use deck stiffening stresses to minimize torsion. Resonance is another interesting force because it is a topic in sound and is also present in bridges. It is a vibration in an object that is caused by an external force that is in harmony with the natural vibration of the original object. These are some of the famous bridges. This is a truss bridge. This is a cable-stayed suspension bridge. This is also a suspension bridge. Now we can see the bridge taxonomic chart by principal forces employed. If the principal force employed is a compression, we can go for the arch type bridge and Roman aqueduct, and again truss arch we can, and again arch in the form of moon or clappers, trestle. When the bridge, the principal is force employed is bending and shear, we can go for beam. In that we can opt plate girder, we can go for tubular plate girder. The skyway, jetways, box girders are the form of the tubular plate girders. And we can, if you prefer the box girders, the cable-stayed bridge are the choices. Compression and tension. If the principal force employed is compression and tension, we can go for a trusses, a compression arch. If the principal force employed is a simple suspension, we can go for suspended deck or the suspension bridge or self-anchored suspension bridges. Thank you.